Okay, I'd like to finish up 4.2 by looking at this proof right here. This is an element proof. This is a really common thing to do with sets. So when we have sets and we want to show that one set is a subset of another, what we need to show basically is that if I choose some arbitrary element in some set, right, I can show that in fact it's also a member of the other set. Right. So in this case, we have a set D and we have a set C. We will want to show that D is a subset of C. Like that's, right? So what we want to show, like they say it here a little bit, right? We want to show that D is in fact a subset of C. Right. So if I suppose that X is an arbitrary element of D, I'll use the definition of what it means to be in D. So in this case, you know that D was things that are divisible by 9. Right? So it says that if X is in D, right, which I'm supposing, I know that from definition that X is equal to 9 times some integer K. Right? It says we want to show that X is an element of C. But, right, since X is equal to 9 times K, it's easy to see that X is equal to 3 times 3K, which shows that X is in C, right? As they say, since 3K is clearly an integer, right, because 3 was an integer, we know K is an integer by initially what we're doing here in our definition of D, right? We know that that is an integer. So there we go, right? It's pretty straightforward. This may seem like almost trivial, but things get more complicated, right? Something kind of interesting is that if I can show something, right? Like if I can show that D is a subset of C and, right, that C is a subset of D, what I do here is I prove that C and D are equal to each other, right? These sets are equal. They're equivalent sets. They contain the same elements, right? So that's something interesting that to look forward to on there. All right. I just thought it would be helpful to kind of think through what's going on in there. And this proof is actually somewhat similar to the types of proofs we had done earlier, some of the direct proof methods that we've seen already. Right, thank you.